In this video, I'm going to be going through the 2021 Engineering Studies HSC exam, and in the first question, we're looking at a third angle projection. Even if it didn't say third angle projection, we should be thinking that it is if it's under Australian standards. And we're going to be, in Australian standards, we have third angle projection with top view on top. So straight away it has to be A or B. And then it says the front is the circle, no pin, and the pin's at the back. So we get circle with a pin at the back, A. If I was making this question, I would maybe make something that was the mirror image of this. And I think that would be a much harder question. This question was answered pretty well. The next one is about black boxes. The only questions conceivable is it keeps the flight data and cockpit conversations. You can make this question much harder. The same thing about fiber optic cables. The only answer that mentions light is B, infrared light. Again, you could ask a question that's much more difficult that asks why you use infrared light. I've included some information about that in my Google Classroom. Okay, so next we're talking about dimensioning to Australian standards. This type of dimensioning we see here with just the single line at 45 degrees is very commonly used in industry. It's done because it's very fast, especially if you're going to get a draftsperson to sketch it later. The thing that rules these out quite quickly is we can see inconsistencies. We can see these arrows here and the mix of these arrows, but we should always be using full arrows like we can see here. Now another reason, so we're ruling out A and C, which gives us B and D. And here we can see that we have inconsistencies of here the lines are drawn in the middle and then here they're drawn above. Now there are AutoCAD settings that will draw the lines in the middle, but we should always be writing above the line and to the left of the line. If I was writing this question, I was going to make it more difficult. I would do things like I would have the 11 written on this side of the line, and I would maybe have the 25 written on the inside and rotated 180 degrees. If I wanted to make it more difficult, because I think a lot of people struggle with that. You can remember Beyonce writes to the left, and you can also think the number 4 points to the two sides where you should be writing all your dimensions. Okay, question 5. Which one is the job of aeronautical engineers? Now, when we talked about aviation, we talked about disciplines that are allied, and we talked about how the runways are built by civil engineers. We didn't talk about carousels being done by, say, mechanical engineers. A friend of mine is a mechanical engineer, and that's what he does. But the answer, the only one that relates to aeronautical engineers would be the noise heard at ground level. Okay, so with this question, it's half mv squared. So first of all, now how do we get that? That's in the formula sheet. You don't have to memorize that kinetic energy equals half mv squared. But what we're going to do is we're going to take 400 tons is the same as 4,000 kilograms, or a ton is the same as 1,000 kilograms. So if we convert tons into kilograms, we're going to get 400,000. Now, it's important to remember that we don't need to multiply this by gravity. The reason we don't multiply by gravity is because it's half mv squared, not half times weight squared. So it's no g is in this equation. Don't forget to square the first. I made an error. I had to start the video again. Don't forget to square it, especially when I'm not writing on paper. I tend to make those sorts of mistakes. So I would urge you, even in these sorts of questions, write in the space here. It won't be seen, but the advantage is if you make a mistake like that, that there's no answer there where if you've forgotten the square that you can say, oh, I'm going to click this one. Okay, so all of these questions were answered pretty well up until this point. Question 5 was a little bit harder, but still more than 2/3 of people got that right. Okay, so here we've got, we should be able to identify that this is a zero force member straight up, that we can see three members meeting at a straight line. That's going to be a 3-force member. In this particular case, they've made it easy for us by actually making them horizontal and vertical, which makes it easy to talk about. We can see that member 1 has a horizontal component. Member 3 can't take a horizontal component, so the entirety of that horizontal component is going to have to be taken by member 2. If member 3 has any vertical component whatsoever, it's going to push out, and there's neither member 1 nor 2 can resist that moment, therefore it must be 0. Now, because member 2, if we have 200 kilonewtons going to the left, Well, member 2 is going to have to provide 200 kilonewtons going to the right. And if it's going to the right, it's going to be pushing into the node. We know that if we're pushing into the node, that it's in compression. So we're going to get compression and 0, which is A. Yes, 7 is A. Okay, so I really hate gears. The gears are something that I, still really struggle to remember with. I can do it when I am doing bike questions because I know where the NREV goes. But when we're just talking about just gears, I tend to get myself into trouble. So I haven't really gone big with this meme yet, but it's not a great one because I showed it to one person. They said, "What even are those movies?" This movie was not a hit. Drive was pretty well known. Okay, so driven over driver. If you think about driver over driven, that doesn't make a sentence. But if you said driven over driver, I drove over the driver. That as a sentence that makes sense. Driven was a movie about the guy who made the DeLorean, the car from Back to the Future. Drive has a character who has no name, and in the credits is just referred to as the driver or just driver. It's got Ryan Gosling in it. Drive was definitely the much bigger movie. Okay, so when we take 25 divided by 80, we're going to get a number less than 1, which is A. Okay, so a pitot tube supplies 2 pressure readings, total pressure and static pressure. These readings are used to determine I'm going to risk being wrong on the internet here. Let's have a look. B is correct. Okay. Dynamic pressure. Okay. So the sealed pressure is the pressure that is in our altimeter. The static pressure is the pressure that we're comparing for when we're talking about the airspeed indicator. Hydrostatic pressure is when we're talking about things like dams and watches. I got something wrong where I was talking about hydrostatic versus sealed pressure earlier this week. But remember, we're talking about sealed pressure is when we're talking about things like Pascal's principles and sealed containers. And not being a chemistry student for well over 20 years. No, more than 20 years. Not something I'm as focused on as the students who are doing chemistry tell me. Okay, so this what we're looking at is compression molding. This is done for thermosetting polymers. I just did this with my Year 12 because I did aeronautical materials last, and this is in compression molding and transfer molding in the Copeland textbook, and we just talked about that. Okay. Which radio transmission is least likely to have static interference? Least. AM is the one's most likely. Oh, good. That is the answer. Okay, most likely to have static interference. It's a good question if we're talking about something else. So pulse width modulation is a way of dimming lights digitally, right? Where if we just turn the thing off and on really quickly, it will emit less photons, and our eye will perceive that as dimmer light. DOB is phase modulation, so it's the one that is least affected by the Doppler effect. But I'm pretty sure I would say that frequency and digital modulation are both pretty well unaffected by static interference. Anything beyond that is outside of my expertise. Okay, so straight away I can see that this is going to be a proof stress question, and so we've got a metal that is under progressive yield, and we're finding the proof stress. Boom, C, 12. Okay, 2 identical aircraft traveling at this speed. Okay. Oh, okay, first of all, I think it's interesting to talk about questions that are answered poorly. So, question 8. I'll just quickly go back. I hate going back, but, I never look back, darling. Question 8 was, gears. That makes me feel so much better. Only 40% of people got that one right. I hate gears questions. 12, very few people knew about proof stress. So if you struggle with that one, you were not alone. And then even less people, so less than half got that one, and even less got question 13. Okay, so 2 identical aircraft, Q and R, are traveling at 500 kilometers per hour. Q at an altitude to Q is at a low altitude and R is at a very high altitude. They're traveling at the same speed. Okay, well, we get more drag at lower altitudes. So Q is going to have more drag. Compared to Q, R, okay, so yes, thank you. R will have less drag. And then because we also get less lift. The reason we get less lift is because there's less air at lower altitudes, part of our hydrostatic pressure thing. Because there's less air, we're going to have less drag, but we're also going to generate less lift because less air is passing over the hydrofoil, the aerofoil, and so the answer is A. Okay, we've got a beam. Oh, bending question. I like bending questions, especially if they're just 1 mark and we just plug in some numbers. So we have a formula. Now you need to know that this one here is the bending formula. I usually write a little lowercase or subscript b here, and it's my over I. Now you need to know that my is actually 2 separate things. The bending moment, y is the distance from the neutral axis to the extreme fiber. It's not a very short name. And I is the second moment of area, or also known as the moment of inertia. So look, what have they given us? They have given us the beam second moment of area. That's the I has been given to us. It's been given to us in a convenient 10 to the power of 6 millimeters to the power of 4, which is what I love. That's what they should be giving it to us. That's the industry standard. Copeland is the one he's the odd one out by doing everything in meters. I don't want to convert millimeters to the power of 4 or meters to the power of 4. I'm just going to use whatever they've given us. So because everything here is being shown in millimeters, we're going to get an answer that's going to be in megapascals. Which again is fine because all of our answers here are in megapascals. So what we're going to do is we're going to take these values. We're going to take, now this thing here, 250 is times 10 to the 6. Why? Because there are 1,000 newtons here, kilonewtons, and there are 1,000 millimeters to a meter, and we want to convert everything to millimeters. So we're going to say 250 times 10 to the 6. Now the y value is the tricky part, right? So the y value is the distance from the neutral axis, which is right in the middle. So we could just say half the height. So in this case, we could say 30 plus 30 is 60 plus 140 is 200. Half of 200 is 100. Another way we could say it is 70 plus 30. They've chosen numbers that are really convenient. So the answer here is going to be 100 is y. So we're going to have m, which we said was 250 times 10 to the 6. I'm writing this on a piece of paper. 250 times 10 to the 6 times 100 divided by 76.96. Okay, the times 10 to the 6 is crossed out. So what we're going to get is 250 times, 250 times 100 divided by 76.96 equals B, and that's right. Okay. I would have rather have written that up on the board and gone through it, but we didn't. Okay, which of this is the most suitable for a spring in a telecommunications component? Now, there's an argument to say that if you were worried about corrosion, if it was in a very corrosive environment, you might use brass or copper zinc. And if you said that for some reason it was, well, I mean, so we've also talked about copper cadmium is wherever we have large diameter cables where they need to have, they don't soften as much under heat. But the other one that we use other than ETP is copper beryllium. Boom. Now, ETP is the one that we use by default. It has excellent conductivity. There is an even better one, OFHC, but given the options we have available to us, it's going to be this one. We do use aluminium for transmission lines because it's light. I couldn't tell you what kind of alloy it is. And annealed copper, so we talked about copper zinc. We could be talking about corrosion environment. The fact that it's annealed makes it less likely. So I know that there's been several questions in recent years, and the answer was always copper beryllium. So, okay, here we've got a diagram which shows two transistors, and so those two transistors are acting as a switch. The current is going to flow from positive to negative. The electrons flow opposite that direction, but the current we're going to say is going this way. We've got an LED here and a resistor. So what's going to happen if A is closed? The electricity will flow through that and the light will turn on. If B is on, same thing. If they're both on, the light will work. The only situation where it won't work is if neither of them are on. So we call that an OR gate, which is 16 is A. Let's have a quick look to see, as we're getting to more complicated questions, which ones people have struggled with. So yeah, 15, that one is, I think, the worst answered multiple choice. Only 1 in 3 people got, oh no, we've got another one that's a doozy coming up. This said, 16 was not answered well. Most people got it wrong. 17, yeah, this one was it was, only 1 in 5 people got this right. This was a difficult question, in my opinion. Okay, so which of the following is a specialized test used to determine the compressive strength of cured concrete? Well, slump we know is for workability. So then what we have is the Jenker hardness, the Shaw hardness, and the rebound hammer test. So when we're talking about compressive stress, right? When we're talking about compressive stress, hardness is generally associated with tensile strength. So that's where I would be more inclined to go with this one. That said, there's a reason why this question was answered very, very badly. And I think that when we were saying that less than 1 in 5 people got this right, that means that there's a 25% chance of people just being able to guess it correctly. That said, my best student, she was able to use, apply her, she had a system when I spoke to her after the exam, she was able to say that this is how I came up with my answer. I said, well, the other ones were, it says it's for a compressive strength test. So that was how she came up with the answer. But look, it's tough. I haven't talked about these tests as a standard practice. They're not in the Copeland book. And I always say that there's going to be a couple of questions in every paper that you're taking a chance on. Every test there's questions I don't like. Okay, so we've got an electric scooter. What was the reading in the ammeter? So what is the current of this circuit? Okay, so I'm going to do this really quickly. So we've got a formula here where it says when we're talking about things in parallel, it's 1 over RT equals 1 over 1. I'm not going to read that. You can read. Okay, so what we can see here is that if we add these two in series together, we're going to get 3, which gives us 3 over 3. Now, I've done this question specifically with my class. I think I've got a video on it. It's definitely in our question on parallel resistance. And I'm happy to go through it in person. But for now, because I'm going to go through this quickly, we're going to say that if we have the same resistance top and bottom, we can just divide by 2. So that's going to give us a resistance of 1.5 ohms. If we have the same resistance on 3 in a triple set, we divide by 3. Now, that's not showing any working out, but that will be sufficient for this video because I haven't written these out in paper. Okay. If you look at my trial paper for 2021, wait, what are we, 2022? Sorry. If you look at my trial, I have a question. I think I literally have this question. As a matter of fact, you can see my working out there. Okay, so what would the reading be? So we've got 18 volts. So V equals IR. So therefore, we're finding the current. So current is going to equal V divided by R. I can draw a little triangle. I think I did that in the other thing. And we're saying voltage is 18 and resistance we said was 1.5. So it's going to be, there's only one number here that's bigger than 18. Yeah, so it's going to be C12. Okay, half the class, half the people in the state got that one right. So, yep, good. Okay, this one here, there's a couple of ways of approaching this. So question 19, this was the least well answered question in the exam. So a couple of things to look at is, for starters, if you don't have a protractor, and a lot of students go into the exam without a protractor, so that makes it difficult. What we're going to say is that if we know the force on this, so two ways we can solve it. One is we can do it graphically, where we can draw we know that this force has to be going up. This really would be... Are we going to go to paint? We are going to go to paint. Let's do paint. Okay. We're going to need that. And... Okay. So we'll just do this really quickly. So we're going to say that this line here has to be going straight up, right? Because that's the nature of a roller. It's not perfectly straight, but it will do. This line here, we're going to say, well, that's going to be our point of concurrency. Sorry, this is where those two forces meet, which means that this third force must also meet at that location. And if you were to measure that, you'll see that the angle is exactly half of the other angle, right? Relative to the horizontal, it's going to be exactly the half of the angle, which is going to be 7 degrees. That's one way of looking at it. The other way we can look at it is mathematically. We can say that the vertical component of F, the reaction here is going to be half of F and half of F. Does that make sense? Because the force is being applied to the center of a single beam, so it's symmetrical. It's at least in terms of vertical forces, it's symmetrical. So it's going to be half F on either side. The vertical component is going to be the same as the vertical component of F. And as a result, we can say, well, then we're going to have, if we have the same horizontal component, but only half the vertical component, we can know that the angle is going to be half. That's the other way of approaching it. Okay, this last question, about a third of the people got this right. This was a question when I got to, when I was talking with HSC markers, a lot of people were discussing this question. I actually thought it was a good question. It's hard, but you want question 20 to be hard. I don't like any question that does not give you the galvanic series. I was looking at an independent paper that didn't give you the galvanic series, and I don't like that. I think that you should always be giving the galvanic series if you're talking about galvanic corrosion. Now, what we're looking at here is the materials that, even if they don't have to label the anodic and cathodic, you should be able to recognize that gold is less likely to rust. It's more likely to be the cathode, and that magnesium and aluminium and zinc should be at this end. So I always think that look for zinc is usually the one that we show as is the one I think of A to Z. Okay, so in this situation, what they're saying is, and we know that steel is usually in the middle somewhere. Okay, so we've got aluminium and steel. So which of the components is likely to corrode? Well, we've said that here that the thing that does the corroding is going to be the thing that is closer to the anode side. So that the electrons are going to be taken from the anode to the cathode. Now, if we're saying which one is the best scenario, which one is the component that is likely to corrode in the shortest amount of time, which is the worst scenario? Well, we want the scenario where the thing that's going to corrode, there is a small amount of it because it's going to run out of electrons faster. So here we can see that in this case, did they not give us steel on that galvanic series? Huh. Okay, I'm just going to work on the idea that the steel is usually in the middle. So in this situation, I'm going to say that... Oh, okay, copper. I didn't realize that not all aluminum. That makes sense. Okay, good thing I looked at the whole question. Okay, so... Not giving us steel is odd. Okay, so copper is less likely to rust than steel. I remember think of steel as think of it as being the dead center. If they don't give us steel, oh, they give us iron, of course. Okay, sorry about that. Had a little bit of a break there for a second. So we have to know that steel is made from iron. That's fine. Yeah, and like I said, it's usually in the middle, as we can see. Okay, so copper is, if we look at copper, it's more likely to steal electrons, and it's going to take from iron. So if we have, of the copper ones, let's have a look here, copper and steel, if we have a choice, the distance is definitely something you should consider, right? But here we've got the distance from iron to aluminium is a small distance, the distance from iron to copper is a bigger distance. That will help us to make the decision, right? That's why you notice as soon as I saw copper, I just instantly dropped down to copper. Okay, so copper, it's going to steal electrons from iron. So in this case, we're going to look at, okay, and part of the other reason why I think about this is that we know that aluminium is a more passive material, the same as stainless steel. It has a passive oxide layer, and that corrosion is usually not as big an issue because of that. It's not going to have a runaway corrosion problem like steel does. When steel rusts, it continues, it creates a feedback loop where the rust is going to continue. Okay, so which one is the bigger issue? Well, here we've got big steel sheets which have lots of electrons to have stolen. Here we have one small rivet with fewer electrons to have stolen. So I'm going to say that D is the worst case scenario, and yes, D is correct. Okay, so we've done a multiple choice, and let's keep going. Now, it usually takes me a longer time to do the multiple choice when I'm recording than it would take me in real life, and I usually go through these written questions pretty quickly, and the reason for that is because I don't actually have to write. I don't have to take that. I can speak faster than I can write. Okay, so some large cities, large spans. Okay, outline 2 ways in which the construction of bridges affects society. So outline is, in the glossary of HSC keywords, outline is a really nebulous one. I never like using outline. I do. I'm not saying I don't, but glossary of HSC keywords, and if we go to outline, sketch in general terms, indicate the main features of. How does that help you? It doesn't help you. Okay, but the idea is that they want you to write some amount of stuff. It's 2 marks, it's a question A, so they're going to be pretty lenient. Okay, I would say, now if you just identified, you're not going to get the full marks. Maybe you could say it's similar to a describe. I think it's probably pretty similar to a describe. It's if we're doing the rest of our cube, so we want to underline society, we want to underline bridges, we want to box the number 2, right? That's really important. So what are we going to look at for E? So we're going to expand. We're going to have 2 things. So let's say the first one we'll talk about is safety. The second one we'll talk about is environment, right? Because environment affects society. You might want to choose, say, convenience, right? Let's go with convenience just because that's a little bit more distinct from environment, and that will give us a better answer. It's a better demonstration. You can consider economic and environmental factors as separate things, as if you want to extend your own study. Okay, so the first thing I would say is bridges provide safety. For example, the Sydney Harbour Bridge, deaths were caused due to ferry sinking. The bridge reduced the loss of life in crossing Sydney Harbour. The second thing is we can talk about convenience. By building bridges, this usually reduces travel time, which means that it reduces the inconvenience. The saving in traffic time is considered a benefit to society. That's sufficient. Let's have a quick look at, I'm not going to go through this drawing either. So you should absolutely expect in every HSC to see a threaded section, right? It's just every single HSC. The fact that I did a trial and all but one of my students didn't draw it in section, even though it said fully section the drawing, is astonishing to me, and probably a failing as a teacher. You should absolutely be expecting to go into the HSC expecting to do a threaded section. Okay, so let's have a look. Reducing commute time. Yep, okay, good. People can meet more socially from either side. Greater use of infrastructure, schools. Yeah, okay, potential increase in leisure time. I didn't say leisure time, I just said that generally it's considered a positive, reduction of travel time is considered a benefit. Okay, so this question, I think for 3 marks is not bad, and it gives a good indication that when we look at drawings, that just the idea of being able to draw a bolt is worth 3 marks. We haven't talked in my class as much as we should have at this point about scales, but luckily we've got several weeks to the HSC, so I can go through that. But what they've asked you to do is, what are the marks we're looking at? So first of all, we've got a fine thread, and we know that it's a fine thread because there's an X2. And so that means that the internal, or the d min, the distance from either side of these lines, is going to be 16 minus 2, which is 14. If they didn't give that, we would have done 80% of 16, which would have been slightly less. 16 times 0.8. Okay, which would have been 12.8. They want you to draw the 100mm bolt. That's fine. They want you to see that the thread length is only 50mm. They also want you to know the thickness of the bolt here, right? So the bolt head, it's interesting that it's labeled that. Okay, the bolt head, so we say head at 7, nut at 8. So it's 0.7 times 16, which is 11.2. And the width of this face is 0.9. So we've got 7, 8, 9. This is the 9, right? So this should be 9 wide, this distance here. And then across the corners is 18. So 0.8 times, sorry, 1.8 times 1.6. So I like to remember that these two lines should always be in between the lines of the thread, right? Because if this is 0.8 and this is 1 and this is 0.9, well, that's going to be in the middle. This isn't exactly 0.8 because it's a fine thread, but it's pretty close. And we generally will show bolts. We should be showing bolts in across the corners rather than across the flats. So I think that's as much as I want to go into. I don't want to label the point too much here. I think it's a good question for 3 marks. Yeah, if I'm ever looking for 3 marks for a section question, I like it. And it frees them up to ask another drawing question later, which is good. Okay. Yield stress of a bolt is this, the diameter is that, the factor of safety is 2. Okay, so if you're ever seeing something like stress, I was talking to a student and she was saying that, well, she didn't know what to do. And it's like, well, if they've given you stress and they've given you a diameter, it's pretty easy what you're looking at there. Now, they're not saying if the bolt is under double shear or anything like that. What they're saying in this case is that we're considering the bolt is a factor of safety of 2. So what we're going to do is we're going to get an answer in kilonewtons and then we're going to halve it. Right, will be how we approach that question. So we could say stress equals force over area. They've given us stress. So to write area, so just where I got that from, stress equals force over area. Stress equals force over area. So we can rewrite that formula to say that force equals area times stress. And back to the paper. Force equals area times stress. And I should just give an idea. So this one here, the average mark was 2 for that one. And here the average was also 2. Most people got 2 for this. So stress equals force over area. And we're going to say that force equals area times stress divided by 2. So we're going to say the area. Now, to calculate the area, we're going to say 16 times pi, so pi d squared. Sorry. The area equals 4d pi d squared on 4. Sorry. I just had a blank. I was thinking about something else. Okay, so it's a hard one not running on the board, but we're going to go with, so it's 4 times 16 times 16. Sorry, again, I have no, now I'm thinking about my mistake and now I'm like spiraling. Okay, so pi times 16 times 16 divided by 4. Okay, so 200, nice easy number that they've given us. Okay, 200 times 476 divided by 2. Okay, 47 kilonewtons. Let's see if I'm wrong. Good job. Okay, I don't know why I didn't just get the answer, the written up answer up first, because you all know how much I hate being wrong on the internet. Okay, so they've divided the stress by 2. That's fine. It's the same thing. They've used pi r squared, which I hate, but I understand that, you know, after 10 years of maths teachers teaching you that it's hard to unlearn. I'd say if you plan on working in engineering, you might as well unlearn it. and I used, because we're using megapascals and millimeters squared, the answer all works out. And then I got an answer in kilonewtons. Okay. So I get an answer in newtons, and then I convert it into kilonewtons because they asked us to use kilonewtons. My opinion is that they probably would have still it's entirely possible that you would still get 3 marks even if you didn't write the answer, if you didn't convert the answer into kilonewtons. Especially if you wrote the answer here in newtons and then wrote it again down here, I think they would definitely give you the right answer. They would look for the right answer anyway. Okay, this is a good question. Sketch below and label the components the macrostructure of reinforced concrete. So macrostructure is what you can see with your eyeballs, and we have some samples at school where we just show what concrete looks like if it's shown in section. The problem is I can never find any really great pictures of this on the internet. So let's make a I mean, I would love to be able to just quickly find. I'll even click on this video, which, you know, I don't like videos. Okay, so that's kind of what we look like when we're cutting through the side. But what we want to look at here is we want to see the steel. That might be a steel. Oh, I don't think so. I think that's. We should be able to see the steel reinforcing bars. Now, this is the sort of thing that at uni you're just drawing all the time. So you're drawing. When you're doing concrete beams.
This video is going to cover how.
Let's see if we actually see the concrete once it's been cut. No. I knew enough to not hope. Okay, so we're going to draw something like that, and then we're just going to draw some black circles for steel. Is what we're going to do here. I did find some like engineering drawings on how we draw this, but let's just have a look at what the HSC said. Okay. They drew the bars running along the page. I would have just drawn them as circles. I just would have colored in black circles somewhere. Now, they've done bulk aggregate, and then they've done sand fine aggregate, and then the hydrated cement. I would have just drawn dots for the sand, and then I would have drawn, typically when you're sectioning concrete, you just draw circles and triangles. So I wouldn't have drawn it exactly like this. I think there's also, yep, that's great. I would have accepted that. Yeah, I'll just draw it like concrete section hatching. So this is kind of typical. When you're drawing concrete, you just draw triangles and circles and a bunch of dots. And then here we go. For reinforcing, this is actually a pretty good drawing. I'm happy with this. Google Images, you used to be cool. It's not going to be a big drawing. Okay, see, and then there's like, we've got steel bars going all the way through everywhere, which is not great. Anyway, look, if you drew something like that, I would be happy with that. Like, probably be better if it's spelled hatching, right? But like you can see here, the hatching. I mean, I know I went looking for this and I didn't find anything I like, because there's no steel being shown in these drawings, which I don't like, and that seemed to be the problem. Yeah, none of these drawings I can see the steel. Go with concrete beam. Okay, yeah, this looks okay. Something like this. Oh, here we go. This one looks good. Now, that's what I would have drawn. Yeah, just draw some dots for sand. They've drawn some dots for sand. Now, here's the key. If they say and label, sketch and label, if you don't label, you will lose marks, right? So let's have a look. Provides some relevant information. Identifies correct components and parts, right? Provides a partially correct sketch. Provides a sketch of the macrostructure with labeled of component parts. Now, if you didn't write hydrated cement, I don't think you're going to lose marks, right? I would guess. What is this question? 21C? Yeah. Most people only got like less than 1.5. So, yeah. You know, if you struggle with that, I can see a lot of people would have struggled with that. I'm pretty sure I've drawn some concrete for my classes, and they felt confident when I talked to them about it. But you know, it's one of those things we haven't seen that sort of thing in HSC before, so it's good we're talking about it here. Okay, so here's the top view that they've asked us to draw. It's probably better that I show this rather than. I worry that because I don't actually keep this in the drawing most of the time. Or maybe I did. I did. Okay, there we go. Where was my marker? You're seeing behind the curtain now. Okay, so it was there, so that it's always in the diagram. Okay. So what would I look at? So it's important that you're given these dimensions, right? You're given like this point here and this point here. So you know where the circles are going to be. I wouldn't have necessarily shown the hidden detail on the top view. Did it ask us to? Do not dimension, construct within the dashed line below. I mean, they told us where it needs to go, so that's nice. They really helped us out that, you know, you can't be too far out. The thing's symmetrical, so where I think is an interesting trick is this line here. I think this line here is where people would probably, that would be, I would say, the line where I would expect the difference between most 3s and 2s is that those two little lines, if people remembered that. But I don't think you would have lost lines for marks for hidden detail. I certainly wouldn't have expected that. So and I don't think that they would have necessarily expected center lines. I would have liked to have thought that I would draw center lines, but I don't know if that would be. I can't say. I didn't speak to anyone who marked this question, so I don't have any insight on that. Okay. The base plate is to be cast. What are the advantages of die casting over sand casting? Okay, so no cube to help us here, right? There's no key word. It says advantages, so I guess I would underline that. I would say underline pressure and over sand. Okay, so what I would say is pressurized die casting is probably going to give a more accurate finish, and it's better when mass producing. I would then expand that. I would say that sand casting is more likely to produce a rougher finish, and die casting is preferable. The die casting, although costing more to produce, is better for when mass producing large numbers of items. Something like that. Okay, what did they say? Smoother finish, pressure die casting provides better dimensional accuracy. Good answer, I like that as well. Because we're using pressure, we're less likely to get voids. It casts a permanent mold, economy of scale. Yep, pretty much exactly what I said. Okay, so we've got a question here about amp hours. Now, this is something we're seeing with increasing regularity in the last years, especially in independent papers as well. So the idea here was, when we're talking about amp hours, is that we know that power, so power, we have the formula, fight the power FE. We know that power is also equal to work over time, but power is also equal to volts times current. Now, in the formula sheet, I think they write it as IE or EI or something like that. Here we go. They've given it as power equals I squared R, but they could give, if they were going to write it, they'd write it as IE using because they've got E for electromotive force. They've written it here just to really help you out. Okay, so they've told us the voltage, they've told us the watts, so we're going to find the current, and they've told us it takes 1 hour. Okay. So if we know that we're going to find volts or current, so we're going to rewrite I. And I mean, I can't imagine there are many students who would be struggling to know that I is current, but there would be, I guess, some people, or that amps is related to current. If there is the case, I use the acronym CIA. So C is for current, I is the symbol, A is for amps. So current is equal to P divided by V. So we get power, which is in watts, 0.078. Why am I writing this out when someone's already done it for me? Divided by 48 volts. We'll just go over here. Okay, exactly what I've got here. And then we're to get the capacity, right? Where did this 3,600 come from? That is because we're in Did they actually just write the answer in amps somewhere? Crazy. Yeah, they just didn't write the fraction. Okay, so oh no, just surprising they don't actually have. They've just written it as like those calculators that don't give. I'm from the old school where I'd rather have seen it as a decimal, divided by 48, as written as that number. Yeah. Now, the thing is, because it's 1 hour, so because they've made it an hour, like they've just, I think that this is the HSC trying to introduce the concept that these sorts of questions with amp hours as being something you should be prepared with. And the idea is that if something is draining 1 amp and we know the battery has 40 amp hours, well, it's going to run out in 8 hours. Sorry, 40 amp hours, it's going to run out in 40 hours. If it was draining 2 amps, well, it's only going to get half as much, so we'd say 20 hours. That would be the idea, I would say. Okay. A skateboarder is at rest at the top of a slope, indicated in diagram. Combined mass of the rider and skateboard is 80 kilograms. Calculate the speed of the rider in meters per second at point if the average work done by friction against the skateboard is 55 newtons. Now, this is a good question. I like this. I like that they've given us the height. They've stated it's not to scale. You shouldn't expect it to be, but they've given us the value, right? Because typically the question like this, what there would be, it's pretty easy for us to convert potential energy to kinetic energy, right? That we kind of expect that. If we go on the formula sheet, we say that work equals force times displacement. Which is also equal to the change in potential energy and the change of kinetic energy. What we can effectively do is we can say that potential energy equals the kinetic energy if there's no friction, and we can say that kinetic energy equals the potential energy minus the friction if that's the case. Now, our displacement in this case is going to be 250 meters, and when we talk about potential energy, our height is how far we've moved from the center of the Earth, which was 27.8 meters. Now, what they've done, so normally the difficult part of this question is that they expect you to do the trigonometry to figure out this height. In this case, what they've done is they've added friction. Normally they'll give us a frictionless surface. So I like this question. It's the sort of thing I'll consider putting in future papers. Okay, so in this case, we've said that final energy equals initial energy minus frictional losses. So our final energy equals, so this is going to be potential energy, which is mgh, right? So mass of 80 times gravity, they use 10, right? Great. Times the height from the distance relative to the center of the Earth, right? From point A to B. And then we're minusing the frictional losses. The frictional losses, it would say, is Fs. So the force is that we're traveling, we said the force was 55 kilonewtons multiplied by the displacement of 250. If you do add all those numbers, we're going to get 8,490. And if we apply the half mv squared, we're going to be able to get, if we get the half mv squared, we can get square root of v squared equals 200, which gives us an answer of 14. Okay, which seems about right, just as an estimate, because if we know that the square root of 2 is 1.4, so that seems about right. Okay. Due to a reduction in air travel, an airline company has to store some of its unused aircraft. Okay, I had a chance to talk to some teachers about this one, so 23. Okay, so this one here was answered quite well. Well over 3/4 got this. So we would say that 2.8 is something that's probably the average mark. Explain why the desert is a suitable place to store unused aircraft. Well, we know that a problem for the degradation of aircraft is corrosion, and we know that because of the lack of moisture in the desert, corrosion is probably less likely to be a problem. Another consideration is the fact that the desert is not usually a in-demand real estate, so that it's easier to access rather than in a highly developed area or in So, I mean, the idea is people might say, why don't you store them at the airport? Well, the idea is that most of an airline's planes are in the air. Very few of them are ever in the ground at any one point in time. With the pandemic, a lot of these planes had to be taken out of the air. They couldn't all stay in an airport, so where did they go? Well, they flew them out into deserts. Now, we'll have a look at what some of the sample answers are. Okay, so some information provides sound explanation why the desert is suitable. Now, it says here you can get 3 marks for one explanation. Now, I would be thinking that for 3 marks, I would probably want to explain, for cubing, explain, circle, explain means cause and effect, and we'd underline desert, unused aircraft, that would be the 2 lines, we'd underline it, and although it doesn't say that with multiple, but when I look at 3 marks, I would think I really want to try and get 2 answers there. But in this case, they're saying they provide a sound explanation of the desert is suitable for, or why it's suitable to store an aircraft. It just says a sound explanation, right? Now, aircraft being made of aluminium is susceptible to corrosion, crevice corrosion, yeah, never mind. They need a dry, warm climate to remain dry. Desert provides this climate at minimal cost. Other answers include wildlife. Yeah, it is high and does not require paving. Yeah, I think that's really the best answer. Is if you said corrosion, the desert is less likely to get corrosion. I think 2 sentences are unlikely to get you 3, but desert is hot. Desert has less moisture. Moisture is bad for corrosion. Desert is cheap. That's how the simplest way I'd give you 3 marks. How has the work of aeronautical engineers helped to improve aircraft safety? Oh, like this is just super easy, like very open. The possibilities, what you can write here. You can say that aeronautical engineers have implemented black box technology to analyze causes of failure and implement those into our design to prevent those causes from reoccurring. They have they conduct regular inspection and maintenance schedules to prevent corrosion. And then you could talk about specific examples. So I guess the one that comes to mind is the redesign of windows have prevented failures by reducing the stress at the corners of windows. That would be an example. I mean, you could talk about by providing more powerful engines. Engines can operate even when there's engine failure. By reducing complexity, we are less likely to have failure. By introducing fly-by-wire, not only do we reduce weight, but we also can add more redundancy, so if things go wrong. By implementing technologies like autopilot, although it has its own downsides, it means that the plane can operate even when the pilot is incapacitated, all those sorts of things. Okay, let's have a look at what answers they said. Many safety features, computer system failures, right? We have redundancy, use of autopilots, change of materials, lighter, stronger. I don't really like lighter, stronger, right? And I'll say why I don't like that as a sample answer is because by being lighter and stronger, it just means that we put less payload on there, right? It makes it more economical. I like the idea of by detecting flaws, by using materials which are less prone to corrosion, by using materials that are less likely to build up undetectable stress failure, that sort of stuff. By using materials which are less subject to fatigue stress, we're more likely to detect all those sorts of things. Anyway, vigilance devices to stop people from falling awake. So we call them like dead man switches. The idea that people have to press a button every so often. Trains have this, so that if you fall asleep, that the train will slow down automatically. Actually, the use of things like beacons, so that if you do have an accident, people will find it. The implementation of everything from the emergency exits to oxygen masks, they all provide additional safety. Analysis of previous crashes. Also, by having greater understanding of the forces being applied to aircraft and a better understanding of materials means that we can better identify causes of potential failure. But I mean, there's just a heap of opportunity here for this question. It wasn't answered as well as this one, as the desert one, but I think that was because the markers were very generous with that one. Okay. A 3-ton aircraft is flying at level constant speed. Using a diagram, calculate the thrust of the plane if the lift-to-drag ratio is 11:1. Now, I remember doing this question, I think actually when you can watch my video where I talk about lift-drag calculations, and I started drawing the triangle out, and I had just done 6 questions in succession that were all drawing a triangle, and I drew this one, and I sort of scratched my head. But even though I haven't thought about this question since then, straight away I can see level flight. I'm actually reading the question out properly. When we see level flight, what we want to think of is a box where we have, hopefully we have a diagram. We do, okay. Lift going up, weight going down, thrust going forward, drag going back. If it's at level flight, all of those forces should be in equilibrium. So if they're saying that the lift is 11 times bigger than the drag, and we can calculate that we know that the lift is equal to the weight, we can say, well, the weight is 3 tons. So that's going to be, we're going to multiply that by 10 to get newtons. So we can get 30,000 newtons, or 30 kilonewtons. Yep, 30 kilonewtons. Divide that by 11 is going to give us our drag, which is 2.7. Boom. Yeah. I mean, I feel like a little bit of catharsis because I know I looked like an idiot when I did that one on the board when I was recording lift drag calculations. Nobody cares, Luke. Nobody cares. Okay. Carbon fiber is an example of a composite material used in aircraft. Describe the benefits of using this composite material in terms of both its manufacturing properties and its in-service properties. Oh, okay. Well, if we're going to cube this, we're going to say the keyword is, we're going to circle describe. So that is features and properties. And then we're going to underline benefits. In terms of construction, underline construction. In terms of both, we're going to box both to remind us we have to do both. There's 2 things for this answer: manufacturing and in-service properties. So here's the answer I would give. First of all, let's do the E, which is to elaborate, right? So we're going to have 2 points. The first point is going to be manufacturing. So we're going to say, well, how do we manufacture aircraft components? We have 2 ways of manufacturing CFRP. We can either use hand layup or vacuum layup. We're going to, for planes, we're using vacuum layup. We're using autoclaves. We're using high quality materials. Now, what we can say is by using vacuum layup, we can have excellent surface finish. We can get very high material properties. For example, strength to weight ratios. And that means that when we can design it to be lighter. And then when we're talking about in-service properties, we're talking about things like fatigue resistance and corrosion resistance, but let's go with fatigue resistance. By the Real Engineering, the Irish guy, he has a video that talks about why the Dreamliner windows are so big. And he says that because the reason for that is because we have massive changes in pressure on planes. And because they go through these massive changes of planes, the plane is effectively growing and shrinking all the time. And that puts enormous load on the plane, especially at the points where there are openings in the plane, which is where the windows are. By using carbon fiber, its fatigue resistance allows us to have larger openings without compromising the strength of the hull. So that's a very long answer, and I'm not writing this down with a piece of paper. So, but I mean, you'll also see I will finish this paper in a lot less time than you have. So, what are we going to say? Okay, carbon fiber, stronger, more complex shapes. Great answer. I talked about by using vacuum forming that we're going to get very high quality finish. But yes, complex shapes is a great answer. Okay, it's stronger and lighter than material replaces. Reduces fuel consumption. Excellent answer. Also great. Okay, the in-service non-distributional strength or isotropic high reductional strength, depending on the nature of the composite layer. Okay. I don't expect people to know the terms anisotropic and isotropic. Isotropic was a game server where you could play the game Innovation, which is interesting. Look at me wasting everyone's time. Isotropic Innovation. Can you still play? Yeah, Innovation, isotropic.org. Yeah, I mean, Innovation is a pretty great game that only uses 100 cards. And I really didn't intend to... Is there anyone playing? No, because we're in US time. Everyone's asleep. But it's a pretty great game. Anyway, you can play it on isotropic. Okay, so... Isotropic means strong in all directions. So steel is isotropic. It's strong in all directions. It doesn't have... This is where we don't have to worry about tensile strength and compressive strength when we're using steel. It's a great material like that. On the other hand, timber, it is going to be equally strong in tension and compression, so it makes for good beams. Its rectangular shape makes for good beams. Concrete, on the other hand, doesn't have that property. But the difference is with steel is that steel is much stronger. There's a big difference between the strength of steel when we run along the grains versus going transverse to the grains of steel. And this is why plywood is a lot stronger than timber of the same, if we just used a sheet of timber, like a timber board. And the reason for that is because plywood has bidirectional strength. Every layer of the plywood goes in an opposite direction, which means it has a two-dimensional isotropic strength. It's still not three-dimensional. If you get thick enough material of carbon fiber, you can actually weave it in such a way that it's strong in all directions. But typically, when we're using carbon fiber sheets, we're going to get two-directional bidirectional strength. I don't know. I just wanted to explain what they're saying there so that you can then disregard it. This answer here is excellent and much better than the answer I gave. I think my answer was fine, but this is just top-notch answer, and I don't always feel that about those answers. Okay, telecommunications engineers working on Wi-Fi. We've got so our home, we have the two router channels, Duck and Chicken and Batcave, and the idea is that Batcave is faster. Duck and Chicken goes into the bedrooms that are further away from the router. That is literally the answer. Well, I wouldn't write Duck and Chicken, but that is the answer we're going for. So how is... if we're cubing this, how is really an explain question, and we're just comparing these two things. So we would say that because it's 2 marks, so it's pretty easy. If you just describe the two, if you just say 5G is faster, 2.4 gigahertz goes through walls, I would pay 2 marks for that, especially for an A, right? Because it's 24A. But if you wanted to be a little bit more, I mean, they're saying how, so if we're going to give the best answer, we would say 5G, because 5G has high frequency, it can provide more bandwidth, whereas because 2.4 gigahertz has a lower frequency, it's more able to, it can travel further distance, but it won't be able to provide as much bandwidth. That's the answer I would give. These people had time to actually sit down and write down an answer, and I'm sure it's better than mine. Yep. Okay, determine how voltage can be tested in a circuit. I do have a on Google Classroom, I have a question about signal testing and strength and these sorts of things. Typically, we talk about voltage. It could be tested with a voltmeter. Generally, in practice, it's measured by a multimeter. Let's have a look. Voltmeter, there we go. Good answer. And a multimeter. I'm not going to read those answers, but pretty self-explanatory. I think these two questions are pretty easy to get. Describe the basic principles of low orbit satellite telecommunications systems. I think I put this in my notes for satellites in Google Classroom. What are the things we're looking for? And I think we've talked about this actually. There were very old questions, like back from 2005, say, that talked about this. So when we talk about low orbit satellite systems, we can say that, well, for instance, the first thing I would say is that they orbit very quickly. So they take about 90 minutes to orbit, so that you need a lot of them if you want to provide full coverage. In the case, we could use the example of Starlink, where they need thousands of satellites to achieve the same thing that could be done with 3 or 4 geostationary satellites. Describe the basic principles of low orbit. It's a very vague question, which, I mean, is both good and bad. It gives the markers a lot of flexibility, that if they can see that nobody answers this question well, that they can be flexible in how they mark it. Whereas it's bad because a lot of people will see this question, just panic, and they won't write anything. So I've at least written that low Earth orbit typically travel very quickly, so that we need a lot of them, right? They take about 90 minutes to orbit. The second thing is that, what are the basic principles? Well, we use a satellite dish. So, for instance, if we use the example of Starlink, and there's nothing wrong with using an example, especially if you're stumped, right? Better to use an example than not. So I'd say Starlink provides internet to homes using low Earth orbit satellite. Each user has a small satellite dish that connects to a series of satellites. Because they orbit so quickly, it has to connect to many satellites. So a satellite, it has to hand over as it goes from one satellite to the other every 15 minutes or so. I can't see low Earth orbit satellites without mentioning things that, like space, the risk of space junk, and the impact that it has on astronomy. But I don't think that I would chuck that in if I was, had space and had time. Why not? You're not going to lose marks for writing that. Okay, so let's see what they wrote. Okay, it takes about 90 minutes to pass overhead. They're only for a period of 5 minutes. I said 15. Because there are multiple satellites, they need to... I didn't say telephone handset, but that's a good answer. Another comes over the horizon, takes over communication. I talked about handover, that's good. Satellite communication satellite identifies being in range. It connects to the base station. Yeah, okay, well, I talked about base stations, a small satellite receiver. Or I hope I said satellite dish. I mean, sometimes when I'm saying these things, I don't see the words appear in front of me, which makes it a bit difficult. I give a lot of excuses. Anyway, this phone signal is modulated. Oh, okay, great. I should have said that it is the information is sent via digital or phase modulated signals in order to take into account the Doppler effect at very long distances. There we go. Okay, I've got another drawing question, 6-mark drawing question. This is quite the doozy. Now, there's no thread here, and the reason there's no thread here is because they included the 3-mark thread drawing above. So they're getting you on threaded section somewhere. The big thing to look at here is that we've got these PCD, right? So PCD means that we're going to shift pitch circle diameter is what it stands for. And what it means is that when we section things, so they're going to say a partially sectioned drawing of the gear has been provided in the following page. Okay. And then it says, complete the section assembly. Okay, so that, I mean, they want us to do a full section. Include break lines where appropriate. Okay, so first of all, we'll talk about this X means that it's a flat, right? Just so that you know what that's going. They've done that for us to help us out, to say this area is flat. It means there's a section line, but we can ignore section lines indicate that there's a circular thing going on there. That cross says it's flat at that location. This here says that there's countersinking. So it means that we're drilling a hole and then there's going to be a countersink there. I do talk about this in one of my videos. It's probably not great, but I do talk about it somewhere. And then we have here some little, we're going to call these webs or stiffeners that are along here. We don't section those. If we do section them, we section them at half the spacing that we normally would. Right? I would say that we don't section them. Right? My practice in engineering studies is you don't section them like ever. Okay, there's a now sometimes I get spot facing and counter boring. I say the wrong thing. This is a counter bore. Spot facing is where it's raised, right? This is a counter bore where it means that we've got one circle within the other. I think those things are usually pretty self-explanatory. The idea is that the hole that got drills all the way through is 30 millimeters, and then the counter bore is 35 millimeters. It's 35 millimeters wide, so a little bit wider, and it goes down too. There have been questions that have asked you to like correctly label that. They were pretty easy, and you could figure them out. But so the idea is here, what we're going to do is we're only going to section. Is there 3 of these? there's 5 of these stiffeners. No, 3. Okay, so even though there's 3 stiffeners, we're going to draw them as though there's 2. And even though there's 5 of these holes, we're going to draw them as though there's 2. And we're going to show them both happening where we're cutting through the section. That's just common practice because, believe it or not, it's more confusing if we don't do that. Okay, the gear, I don't think they care too much about the gear. They've done that part here for us. Are there any holes in the gear? Only those holes. Yeah, this is the gear, right? So the gear is more complicated. What's the, I like that they give us a sectional drawing. What's sticking out of the gear? What's going down the bottom here? Oh, that's the bottom of the second object, the object we're actually drawing. Okay, that's fine. Okay, so I didn't have to draw this. I might draw this, at another time, and I'll make a whole video about this. But I mean, they've given us a good starting point for 6 marks. This is okay, but let's have a look at their answer, and we'll go from there. Okay. Ooh, I like that you could get away with only doing half section because that didn't specify. So it's both of these drawings show the correct answer. Symmetrical objects can be drawn in half section. Yeah, why wouldn't you do that? Okay, so you can notice the thing I said is that even though there were 5 holes, we only show 2. And even though there are 3 stiffeners or webs, we only show 2. I said that you don't section them, right? Because there's 2 materials, we need to do section in a different direction. I feel as though they usually have sample answers of these on the internet. I feel as though I've looked at a lot of sample answers. I don't care enough to look that up now, but yeah, I don't think a lot of kids got that. The sectioning. I feel as though they didn't do the 2 different directions of the sectioning right. In here, we've got a different material again. Now, that probably is at a different angle. This you can see is at 60 degrees. Right, I'll look at it here. This is at 60 degrees, whereas this material is shown at section at 45 degrees. And that's because we've got a different material. I don't know what you're going to call this. I don't know what to call it. This cylinder, that's what I'm going to call it. This cylinder is a different material to that. So we've got 3 different materials we're looking at. Now, did they section? See, they kind of set you up to draw a fully sectioned view rather than a half section view because they've sectioned this gear down below. I would rather that they hadn't done that, but I understand why they did.
It says partially at the top on the other page.
It says that it has been partially drawn. Yeah.
Partially sectioned drawing.
Well, because they haven't partially sectioned in that they haven't sectioned this part down to the hole with the countersinking. So, I mean, oh, okay, and yeah, these lines go that way. Yeah, so they've drawn. You could never get the answer that they've shown here because these lines are already drawn that direction. Yeah, maybe I did see some people doing that way. Anyway, moving on. Okay, question 25. I'll give a quick overview of how I would break these marks down. Now, I will point out that they don't break down the marks by bits and pieces. They do it holistically. They just say, it provides a correct sectioned assembly from the given direction. I don't like that because I like that, for 6 marks, I would rather say that they say mostly correct. Substantially correct means that you can have, say, 1 error. Partially correct, yeah. What are things that people get wrong? So they might not draw this as being PCD, and they might not draw this as being PCD. They might forget to show the countersink. So that's a mistake. That's a mistake. Not showing the right sectioning here is a mistake. So that's 3. 4 is getting this wrong. 5 is just the general shape. 5 and 6, I would say that if you just draw the general shape, you're going to get something. Oh, the break line. The break line would be another thing. Yeah, because this shape continues into the page, right? Like this isn't the end of the shape. This is just they can't show the whole thing. So that's the break line. Though I think you'd get 2 marks just for drawing. Like if you drew something, I mean not a smiley face, but if you drew something, you're getting 1 mark. If you drew something that looks like the correct view, you're getting a 2nd mark. And then after that, they're looking for things that demonstrate the understanding of Australian standards. Okay, let's go through this. Okay, so Control technologies are used in modern vehicles. Outline a basic principle behind the operation of these technologies. Okay. Okay. So this is this answer. I'm fairly confident that for 2 marks, they're going to give you. These are pretty easy marks to get. Control technologies. Now, I think if you said something like, I had a chance to talk to people who marked this question, so I have a fairly good understanding of it. And if you said something like the steering wheel, no marks. If you said, on the other hand, an autonomous system like radar or LiDAR, which detects vehicles in front. If you said cruise control, which monitors the speed of the car. If you said ABS brakes, which monitor the application of the brakes and determine whether or not the brakes need to be released. That's you got 1 mark for just, I think, for picking something, and for choosing appropriate technology, and a 2nd mark for describing it in any way, right? For 2 marks, if you said LiDAR detects how far, so light emitting radar detects how far away an object is, and when something gets too close, it applies brakes. Boom, easy 2 marks. Okay, now this question. First of all, I don't like that it's 2 fixed reactions. I don't think that they should have had 2 fixed reactions, but I understand that the reason why they did that is they maybe didn't want to confuse people and they were trying to help you. The same thing where they say that they want you to solve this using the method of joints. Again, I think they were trying to help you. Okay, determine the horizontal reaction at point A. So because there's only 1 force, if we take moments about B, we can get the moment of A, and we can say that it's going to be horizontal, in order to make it work. Because we're going to have some of the forces vertically is 1500 newtons down, so we're going to have 1500 newtons down, and then we can get the horizontal component. I personally would have much rather if they'd had a pin and a roller. I just think that that's what they should have had here. And I did a little bit of complaining about that. I don't want to make too much of a song and dance about it, but most students, let's have a look, but I think this was answered relatively well. What are we, 25p? 60% of people got this right. So I have enough experience talking to HSC markers to say that if you take any marks, if you write some of the forces about, some of the moments about a location, and you plug in some numbers, you're probably going to get 1 mark. So if you just said some of the moments about B, and you multiplied 1500 by 10, if you did nothing else, you probably get 1 mark. Okay, you can also okay, so we're just going to move on. Okay, because I don't want to get too bogged down. There's written answers, so when there's written answers, this is the sort of thing that I like to do. These as their own standalone Truss question, and I put that up as a Truss question. But and because I haven't written up on the board, it's harder for me to talk about their working out. So let's go through the next one, where we're going to say determine them using the method of joints. Now this is what I really want to talk about. Now, whether or not, if you see using the method of joints, if you get full marks, if you write the right answers here, are you going to get full marks even if you didn't demonstrate that you used method of joints? Well, I would say that it's very hard for a marker to read the correct answer here, the correct nature of the force, and some working out, right? As long as there's some working out, I'd say it's very hard for a marker to not give full marks. It probably is. The best advice I can give you is that if you can't get the answer somehow, you're better off doing something than nothing. Okay, so let's have a look at this truss. And what we're going to do now is we're going to say that... the whole thing is that... just to catch myself out, that I don't want to go back, but... they do specifically say the horizontal reaction, so the vertical reaction is given. I know I maybe didn't say that as clearly as I said. Again, I'm conscious of time. So, okay, let's have a look at this one here. They want us to find... the internal reaction AC is what we're finding. Okay. Okay, so here we go. Here, internal reaction AC. So if we're finding this member here at AC, and we're finding this, they want us to use the method of joints rather than the method of sections. No, sorry, they want, yes, method of joints here for AC. Okay, so what we're going to do is we're going to look at, if we know the horizontal component and of this material here, well then, if we found the horizontal component in the question above, then there's only one place for that horizontal component to go for AC. If we just look at it from that node, at the node A, there's only one place. We talked about before about the zero force member, right, where we had member 1, 2, and 3. Here we only have one member. So if we know the horizontal component, the component has to be the same. So if we've said, now let's say that you didn't know what the horizontal component was. Sorry, I'm confusing myself because I'm moving around. Okay, because we found the horizontal component above, right, as 3,750 newtons or 3.75 kilonewtons, right, we know that component. What if we didn't know that component? Let's say we just had a mind blank, we couldn't think of something, and you wrote 100 newtons. Well, then you can say, well, if there's 100 newtons that are, let's say, if this is going down, then this one has, if this one's going clockwise, we need to have something going anti-clockwise. So let's say we said it's 100 newtons going into the wall like this. If we have 100 newtons going to the left, we're going to have 100 newtons going to the right, right? So the horizontal component of AC has to be the same. In this case, it's going to have the horizontal component has to be 3,750 newtons. Now, we know that the total force has to be the hypotenuse. It has to be a number bigger than 3,750. Now, what is that number? Well, conveniently, it's oh no, it's a 3, 4, 5 triangle. If you know it's no, it's not even that. It's a 4, 5, whatever triangle. So some people, I think, would have answered this question by using Pythagoras' theorem and just saying that, well, there's the ratio. If we know 4, 5, we can figure it out, and it's going to be by the ratio. Other people use calculus. I think would have used calculus. Sorry, oh man, it's not my day. Used trigonometry to calculate what the angle is, but this is within the ability of most people to do that level of trigonometry. My answer is always, if you don't know, draw it to scale. And in this case, the drawing is always given. You know, the truss should. Even the one time when the drawing wasn't drawn to scale, I would argue you're better off using the truss drawn to scale than sitting there blank, not knowing what to do. So that if you know the horizontal component is going to be 3,750, right, and you draw a triangle up, right, like this triangle here, even if you don't know this angle, if you draw 4, 5, and then just scale it, you'll get an answer. And that gives us this answer here of a number that is bigger than 3,750, which is 4,800. Okay. I'm going to keep going. Okay, so the next one, I always prefer method of sections anyway. I mean, I'm on video somewhere saying that the only person who uses method of joints is Snoop Dogg. It's not typically how I would want to go about it. But me personally, I would have done that question using the method of sections, right? That to me would have made much more sense. I would have felt much more comfortable about it. But to do that, what you would need to do is you need to calculate this distance here, d, and or just draw the distance d to scale. This is how I personally would have done it, as I would have used that value here of d. I'm not going to go through too much detail. This question, to be honest, really requires its own, warrants its own video. And like I said, I don't want to go too long. Okay, but what we're going to do now is we're going to do this question, and we're going to find which member, CE. Okay, so we're finding CE, this member CE. Now, what we can do is if we cut through this line, it's hard for me to do that. I can, I guess, go to paint. Go to paint again. And what I can do is draw a triangle that Could I not rotate this object's man paint is terrible. Can I really not do that? Okay, let's just do that. I can't believe how long I've wasted on this. Okay, I would just cut through those locations, right? And what would I use? I would use not the left-hand side, I would use the right-hand side because that only has one external force. Way easier to use. Okay, now if I want to find CE, first thing I'm going to do is I'm going to assume that everything is pulling out of the node, right? I'm trying to draw some arrows as quickly as possible. Now, if I'm finding CE, I can't take moments about C. Or, sorry, can't take moments about C. I can't take moments about E. So I have to take the moments about where CD and BE meet. Where do those things meet? They meet in this location at B. So I would argue for a 3-mark question, first thing you would do is if you wrote some of the moments about B, boom, you're getting a mark. Second thing I would say is if you've then shown on the paper a drawing like this one here, right, where you've shown the cut and you've drawn the things in tension, right, it's pretty hard that you're not getting 2 marks there. But let's see. If you wrote, if you correctly determined that CE has to be in tension, now how would you determine that CE will have to be in tension? That because we ignore BE and CD, they get eliminated. So what we effectively only have is we only have 2 forces now that we have. We have the 1500, which is going clockwise or anti-clockwise? It is going clockwise. So CE has to go anti-clockwise, which we can see is pulling out of the node and make it go anti-clockwise. So straight away from observation, you can get tension. So if you drew this picture and you wrote tension, I would give that 2 marks if it was me. The next thing you're going to do is you're going to say, well, okay, 1500 times 10 versus CE times 5, we can see, well, CE is going to have to be twice as big. So straight away, without even writing any maths, I can say it's just going to have to be 3000. Again, this question really just warrants its own video because it is, it's got a couple of irregularities, the fact that it makes you want to do it by method of joints, and then method of sections. These reactions, it is a little bit of an unusual question. It's a great well, okay, do I think it's a great question? I think it's a good one for you to study, is what I think it is. Okay, let's just keep moving. Okay, now here is the quietest 2 marks you've ever seen, right? It says, how does the process of normalizing affect material properties in these pins? Now, anyone who I've taught in the last year has heard me say that Kanye's cancelled, we no longer talk about stronger. Now, I've been saying that for a little while, that, yeah, talking with HSC teachers, they do not like you to write the word stronger. Do not ever write the word stronger. And the problem is, stronger is such a useful word that I use stronger all the time. I have memes that have stronger, and I had to go back and edit them, because if you wrote stronger in this question, I don't think you got marks, right? You had to say that normalizing provides steel with a higher tensile strength than annealed steel. And if you said that it had less stress than work-hardened steel, or if you said that that comparison, straight away I would give you a mark. The second thing is you could talk about hardness and wear resistance. So hard, they will pay. If you say that normalizing is hard, on the other hand, they're maybe not going to give that to you, right? So what you want to say is normalizing is harder than annealed steel, right? Normalized steel is harder than annealed steel. Now, the thing it says is this, for 2 marks, you can't say it's harder and stronger, right? You can't say, you need to say, how does the process of normalizing create these pins? So what you can say is that by cooling more rapidly than annealing, it creates smaller grains, which result in a material with a greater tensile strength. That would be what the best answer I think you could write. You could also say, I mean, I don't know what else you can use. Yeah, hardness as a feature. Yeah, small EQX grains. So it's kind of 1 mark for each, right? So provides some relevant information, you're going to get 1. But yeah, if you wrote strong, I don't even think you got 1 mark, which is heartbreaking to hear. But normalizing involves, one day when I'm in charge of marking, I'm going to bring back stronger, but it's not going to happen anytime soon. Normalizing involves heating steel to the austenitic region and then cooling in air to produce fine EQX grains of pearlite and ferrite. This results in a material with optimum toughness and tensile strength. That's a really good answer. I like that answer. Okay. Outline a change in technology that has led to the improvement of fuel efficiency in cars. Okay, so a lot of people wrote electric vehicles. You can say that although electric vehicles run on electricity that is often generated by burning fossil fuels, it is still more efficient than using a petrol or internal combustion engine. That would be an answer I would give. What are other technologies that we use? So like the use of hybrid braking means that energy that would otherwise be lost to heat is stored and can be reused. We can talk about by using, say, computerized fuel injection, right? We can provide the optimum fuel consistency to improve the performance of the car. A couple of answers you can give there, right? What do they say? Lighter, more streamlined cars. Oh, great. Yep, using lighter materials and using aerodynamic shapes. That's a great answer. I didn't mention that. Hybrid cars, regenerative brakes, fuel injection. I said cruise control. Yeah, okay. I didn't think about that. More efficient gearboxes and differentials. Improvements in lubrication. Yep, okay. Lots of good answers there. Again, it's an A, man. For an A, they're going to be pretty. There's often a more leniency for questions that are question A than question C. The ramp shows a box which is on rest. The length of the ramp is 3 meters. It's raised 8 meters off the ground. The coefficient of friction between the ramp and the box is 0.5. At what height must the box be raised in order to begin to slide? I mean, my gut says it might be 1.5, but 1.5 meters. What is the basis for that? Well, first of all, you need to know that there's this formula here that says the coefficient of friction is equal to tan theta, right? So tan of 0.5, I think might be 30. No, that's sine of 0.5 is 30. Okay, so I have the answers. I don't need to embarrass myself. Okay, 26 degrees. There we go. And then we use 26 degrees. You can use, like I said before, when they had the question on the bike and the potential energy energy, one of the things they usually want to test there is your ability to do some applied trigonometry. I misspoke and said the wrong thing, but applied trigonometry. This is an example of doing applied trigonometry. So 3 marks. I mean, how many people got this right? Why are we 26B? Yeah, most people got this right. 3/4 people got this right. Okay, explain how a mobile phone maintains communication link with the network as users move the location while making a call. This is a great question. Well, okay, when I say great question, I would hate to see this question, but it's a good question to practice. It's something I may or may not have included into my Google Classroom notes on satellites and not satellites, on signal testing, cell strength, and infrared. Okay, so what would I explain? So first of all, it's a how and why. Mobile phone maintains a communication link with the network as the user moves locations while making a call. So I would say that mobile phone networks have multiple cell towers, and that as you move from the range of one cell tower to another, there is a handover process as it connects to both towers, and then as you move closer to one tower, it hands over to the other tower. It's not a great answer, right? How and why this? By doing so, it provides an uninterrupted communication, right, without any loss, without having to hang up or call again. Let's see what they wrote. Mobile phones transmit identifying code frequency to the base station that receives the strongest signal. As it receives. Yeah, look, I don't love this one any more than what I said. Identifying codes isn't a really interesting part of that. I mean, I'd say it's being on the scope of the HSC. But, here we are. Scope of the syllabus. But, yeah. I mean, by all means, take into account what I've said and look at this. And I have some videos that talk about this. I think I linked to a Wikipedia, which I think does a reasonably good job of explaining it. I would say that this is typically has been a low percentage question. I think that we haven't really seen a question much like this, with much frequency. So I think that you probably don't need to worry too much about it. But you know what? Past HSCs, recent HSCs are a good indicator of future HSCs. By all means, you should be looking at this. Okay, compare multi-mode optical fiber and single-mode optical fiber in terms of light paths taken and materials used. Drawings may be included to support your answer. Okay, so I have talked about this in my Google Notes, and I'm definitely have talked about this in my videos on telecommunications. I think it's probably in telecommunications 2 at least. So what we want to compare multi-mode and single mode. What we would say, so compare. Do we have our HSC keywords? Compare. Show how things are similar or different. Okay. Both transmit light to send information. Both send pulses of light to transmit binary information. Right. That'll probably get you 1 mark. Multi-mode optical fiber is generally cheaper than single mode optical fiber. However, multi-mode optical fiber can travel much further distances without signal loss, and it can provide higher bandwidth. There you go. That's 4. Now they asked for drawings. It says drawings may be included in your answer. So single mode, you just draw the optical fiber in section, and you just draw an arrow, right? And then for multi-mode, you're drawing a whole bunch of curves overlapping. So let's have a look at what they did. There we go. Okay, multi-mode. I would have done as curves. I think it's stepped versus graded index is the difference. Do I want to go to my notes? Anyway, look, we're going to run with the HSE answer. I would have done as curves, but multi-mode optical fiber is used to transmit lights. Short distances are going to be made from glass or acrylic surrounded by cladding. Light can take many paths. A single mode, on the other hand, single mode is made of core of glass. It only takes 1 path. It does not refract, and in doing so, it has less signal loss. And yeah, okay. It doesn't talk about signal bandwidth, but that's okay. Interesting, the difference in materials. I had learned something. I hadn't looked at that answer. I hadn't looked at this particular HSC answer, I don't think. So until now, so good answer. I like it. Okay. Oh, okay, we're in the last question. Okay, so the talk amongst engineering markers was that, how many people got that question? 26D answered horribly. Less than half the people got it. And cell phones answered horribly. Less than half the people got it. What was the other one? 25B2. Let's have a quick look. 25B2. Oh, okay. Yeah, no one got that one. 25B2. 25B2. Yeah, trusses. Nobody ever gets trusses. I mean, that was like only 3 people got this one. I mean, that's right up my alley. Anyway, who knows? Okay, so yeah, this wasn't answered as badly as the truss, but it was answered pretty badly. Okay, so about 2/3 of the marks were given. A little bit less than 2/3 of the marks were given for this. So we'll say that like the average mark was about a 5. In engineering practice, freehand sketching, technical drawing, and computer-aided drawings are used. Explain the use of each of these drawing methods in engineering practice. Support any answer with relevant designs. Okay, so it's explain, right? So we're circling explain, and then for each, we're going to box the word each to remind us that we need to do each of this. So we're saying freehand, we're underlining, technical, we're underlining, and CAD, we're underlining. Now, if we gave an explanation of each of these with an example and a how and why, we're going to get 9 marks, right? Now, it's not possible to get 9 marks, but it means we can mess one up and be okay. So, freehand is used for initial consultation and when developing ideas. Why? It's used because it's very fast and allows for multiple parties to quickly identify problems and to have a shared understanding during discussions. Technical drawings provide an unambiguous detail of what needs to be provided. It can provide a lot of information with a high level of accuracy. And it often forms in contracts that are important for dispute, contracts which not only prevent mistakes but also ensure accountability. And then finally, computer-aided drawings are often used to produce technical drawings and are often used to store technical drawings. However, they can also be used these days for computer-aided manufacture, which is is a way of producing 3D objects, laser cutting. Also, computer-aided drawing allows for things like survey data to be included. So even if you don't know that the survey data is important, it can be used later. Part of my job was most of my job when I used to work in engineering was figuring out where pipes could go underneath train tracks. That was pretty much my job. And so someone would call up and say, hey, we need to put in an extra water pipe. And I would then go and look at the drawing, and I would look at the survey data, which was on the computer-aided drawing, and on the CAD drawing, and then I would say, okay, that pipe, it needs to flow at a 3-degree slope or whatever, and it's going to have to go here. That's the only place where it can go. Or we're going to have to redesign because we can't get enough depth, or it's going to run into something. All of that information was stored on the computer, and even though we didn't know we needed the pipe at the time, it was already stored there, and it provided that information in a way that everyone could access. So I think that's more than enough for 8 marks. This, my understanding, let's see, it was, like I said, the average was only 5 marks, but the feeling amongst teachers was that this was a very easy question to get. Okay, so they're broken up into 3 parts. Freehand sketching allows complicated concepts to be transferred visually rather than, it could be done by hand, it could be done quickly. It prevents, it prevents problems in an early stage of design. Okay, technical drawings communicate specifications, drawn to a standard, unambiguous, transcends language barriers, precision. Okay, then we have CAD, allows for rapid editing, great storage. So with CAM, computer-aided manufacture, we can make a lot of things very quickly. You can do calculations on the fly. Can be used so we can do prototypes in like virtual wind tunnels and like finite element analysis, where we draw up a computer model which can then be tested. So that's good. We could also talk about CAD. I just mentioned finite element analysis. We can have library of objects, so you can copy and paste a whole bunch of things. It can also be used for things like for architectural drawings. It can be used to determine shadows, which is really important. 3D modeling. So I used to sit next to a guy who he did a lot of 3D modeling, so that when we would propose a bridge or whatever, we would get him to draw a 3D model of that bridge, and he'd put cars running over it. And that was really important in order for the state government to, or whoever was the client, to be able to show to other people, this is what your new bridge will look like. And that helps, more so than a sketch on a napkin does, that helps the community to understand the value in what they're proposing. Electronic transfer is really important. If you're working with overseas offices, my office worked with a engineering firm in England to build the new Wembley. When I say the new Wembley Stadium, I'm talking about 20 years ago. 3D printing, collaboration. Easy collaboration, sabotage. I guess there's a thing that. So I worked for a rural council, and they had the bridge designs were on massive pieces of paper that were stored in a massive filing cabinet. And if I needed to get like a measurement or anything like that, I would have to put it very carefully on a big piece of paper. If I was angry, I guess that, or if an employee was angry, it wouldn't take them much to destroy that. 1 can of Coke would be able to destroy a piece of paper that's pretty much irreplaceable. Okay, there we go. I hope that was of benefit to somebody.